Everybody ready? All right, let me get my camera going. I thought you did pretty well yesterday. I was watching your faces, half your faces, and that's really the only clue I have. When I'm looking at you and I say something, I look, and I have to see whether or not, yeah, I got that, or and I'd like to see a little bit more of this. Sometimes you got it. If I knew that you were sitting there and said, I don't think I get that, you say, well, I'm not sure about that. All right, let's go over here, and can everybody see this? All right, I'm ready to start. So what I was trying to tell you, when you're talking about the atom, the structure of the atom, there are two worlds that you have to know about. One of them is the world of mass. Remember that? And that was also known as the world of, help me out here, the world of mass is the world of the nucleus, because essentially almost 100% of the mass is in the nucleus, right? So if we're talking about the world of mass, you're talking about protons and neutrons. And I'm looking at in the nucleus, aren't I? Matter of fact, if I count these up, that's called the mass number. The total number of things in the nucleus is the mass number. And so if the mass number here is 7, and 3 of them, protons, are always the atomic number, that's your identity, that's your fingerprint. Then what would happen, though, if I were to add a neutron? What if I added a neutron to this guy? Instead of him being lithium, whose mass is 7, what would he be called? What if I add a neutron to this drawing right here? What would it be? Lithium 8, and that's called an isotope. Now, which one of these is lithium? Lithium 7 or lithium 8? Which one? Yeah. On the, which one? Okay, isotope. That's what I'm doing now. Isotopes are the world of the nucleus, okay? This drawing here shows a lithium. I know it's lithium because it has 3 protons. Is that right? But what's the mass number of this lithium? And if I add an extra neutron, his mass is 8. But the first drawing, the mass was 7. And anyway, if there are the same elements, but they have different masses, they're called isotopes of the same element. Every atom in the universe is an isotope of some element. Do you understand that? If I picked up an atom and looked at it, well, you're an isotope of helium, or you're an isotope of lithium. Everybody's an isotope. But if you want to know if they're the isotope of the same element, then they have to have the same number of protons, don't they? So when we went over it here, remember the 3 drawings here? Don't those look like 3 different atoms to you? Well, what's different about them? Is it protons? Electrons? No. In the world of mass, or the world of isotopes, the only thing different is I have a neutron, you don't, and I have 2 neutrons and you don't. My mass is 1, my mass is 2, and my mass is 3. Hydrogen, 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 mass of 1, mass of 2, 3. And these are called isotopes of hydrogen. Now, I'm not asking you to memorize all the isotopes of hydrogen. The only one I have on the test is this one. Name the 3 isotopes of hydrogen. And they're only 3 isotopes that have special names: protium, deuterium, and tritium. They're the only ones that have special names. The rest of them have names like this. I'm U-235. My mass number is 235. See that? Carbon 14. So, what do you think about that? If they're the same element, but they have different mass, you know why they have different mass? Because they have different number of neutrons. They're the same element because they have the same number of protons. Now, what I'm going to do is go back now and cross over that brick wall, and this is what we did yesterday, yeah. The world of charge. When you read the chapter, and I'm going to ask you to do something this weekend. This weekend, and I probably won't even pick it up till Wednesday, but I want you to make and I'll put this on Google Classroom. I want you to make a list of any scientist that's in this chapter 4, and I want you to write out a sentence, what they did that has something to do with the structure of the atom. You get that? Now, that's going to be due on Wednesday, but I'd like you to start this weekend, because what I'm going to do on Monday is talk about the scientist. And if you've already done that, then you'll say, I heard about that guy. And I'll read those, and I'll tell you what they did in the experiment. So there are 3 parts to the test. One of them has to do with the scientists and what they did. One part has to do with the periodic table, and what the different parts are, and you've already done that, right? And the biggest part is about ions and isotopes, and that's what we're doing right here. So let's cross over the brick wall again. And one of the scientists discovered that the atom itself was actually made of something smaller than atoms. That was nobody knew that. And this guy's name is J.J. Thomson. And J.J. Thomson, he put a lot of electricity into a piece of metal, into a vacuum tube, and a stream of particles came out, and they kind of were glowing a little bit. He could actually tell there was something coming out. And he eventually figured out that they were negatively charged. So we say that J.J. Thomson discovered the electron. Before J.J. Thomson, nobody knew that the atom wasn't anything except maybe a ball or something like that. And they said, whoa, what's going on here? The atom is made of something smaller than the atom? And so that's how we eventually knew that there were subatomic particles. So the electron had an electrical charge of -1. And the proton has the same charge, except it was +1. And that made sense to them, too. He said, look at this item. If I pick up an item, I don't get shocked. It's not charged. Most things are not charged. They're neutral. But how can they be neutral if I know that atoms contain negative things? And somebody said, they must contain positive things, too. And then they discovered the proton. So the two things that have charges are protons and electrons. Now, you can't, I can't do this for you. In the world of mass, you have to say that's protons and neutrons. That's you. You have to do that. But if I say the world of charge, what are you thinking about? You can't play dumb and say, oh, I forgot. Which ones are in the world of charge? Protons are positive. Who's negative? Who's negative? Everybody. Electrons. So if I'm talking about the world of charge, you go like this. Here's protons. Here's electrons. If you have the same number of pluses and minuses, you're going to be called an atom. Some people call it a neutral atom. What if you have more protons than electrons? Look at my hands. What are you going to call that? You can't call him a neutral atom anymore. What do you call it when you don't have the same number of pluses and minuses? What if you have more pluses and minuses? What are you going to be? What's that? It's a 3-letter word, starts with I. If you're not a neutral atom in the world of charge, you're a, who knows? You know it. I can see your eyes. Ion. Now, if you have more pluses and minuses, you're a positive ion, aren't you? What if you have more electrons than protons? Aren't you also an ion? Negative ion. See that? If you keep doing that in your brain, you'll understand ions. Now, so in the world of charge, we'll never talk about neutrons. That'll never come up if I'm talking about the world of charge. Let's look at our model down here. I have 3 plus charges, and I have 3 negative charges. That's why it's a neutral atom. It's an atom. But I will tell you right now that lithium has a tendency to let a nonmetal take one of his electrons away. He actually will get it ripped off his face. Now, what does that do? That leaves lithium with 3 protons, but only 2 electrons. And I know your math teacher, I know you do this, it's called pre-algebra. What's plus 3 and minus 2? Plus 1. Now, if that's the case, if I had a lithium atom and he had a charge to him, I would have to let you know. Now, how do I do that? In the upper right-hand corner, I let you know he has a plus 1 charge. I'm an ion. I'm looking at your face again. Do you understand the difference? I'm not in the world of mass anymore, am I? Yes?
How did you get that there are 2 electrons?
Okay, I made it up. I said originally he had 3 electrons, and I said in chemistry, I happen to know that lithium, when lithium comes in contact with like fluorine, you know what fluorine does? It'll rip one of his electrons away. Now, the thing that's left over still is lithium, isn't it? See the 3 protons? So he has 3 protons, but he lost one of his electrons. Now, when I was your age, I had trouble with this because every time I was young, if somebody said you lost something, I thought about negative. Isn't that right? But here's what happens. What happens if you lose one of your negative electrons? What do you become? If you were neutral and you lose one of your negative electrons, you become plus 1. You could become positive. You have to fight that a little bit, don't you? Now, metals have a tendency to lose 1, 2, or 3 electrons. Metals have a tendency to become positive ions. And that's what today's lesson is about. So let me turn this over, and let's turn on the back here, see what's going on. Now, this is a big story. This is a very big story in chemistry. If you said you took chemistry and you couldn't tell this story to somebody, they say, I don't believe you took chemistry. So let's talk about this. I have over here a guy named lithium. Now, on the periodic table, you already know, you had to do a periodic table thing. You already know this little stair step, see right here? You already know, not counting hydrogen, that anything below that stair step, all these things are called metals. All of them. Well, metals have one thing in common. They all tend to lose 1, 2, or 3 electrons in a chemical reaction. Okay? Now, hydrogen comes over here, and hydrogen belongs to this little corner group right here, and these are called the nonmetals. Nonmetals tend to gain electrons. So here we go here. Metals tend to lose negative electrons in a chemical reaction. Nonmetals tend to gain. I want you to remember that the rest of the year, okay? The rest of the year, you have to remember that. Now let's take a look. Here's my original lithium. My original lithium had 3 protons and 3 electrons. So he was just a neutral atom, mind his own business. He was neutral. And I had a chlorine atom all by himself. And look at chlorine. Chlorine's number 17. So he had 17 protons. He has 17 electrons. He was neutral. But what happens when I bring lithium and chlorine together? What happens when I bring them together? The metal is going to tend to lose this electron. See it? Now, if you lose one of your negative electrons, what happens to lithium if he loses an electron? Watch. Now he has 3 protons and only 2 electrons plus 1. He becomes a lithium plus 1 ion. Now, look over here, chlorine. Chlorine had 17 protons, 17 electrons, but what did he do? He gained an electron. Look at the numbers. Now I have 17 protons, and now I have 18 electrons. What do you think? What's positive 17 and negative 18? What does that give you? Does everybody understand that? That gives you negative 1, right? And so here's part of the secret of chemistry. Whenever metals and nonmetals come together, now sometimes you have to heat them, sometimes you don't. But the metal tends to lose negative electrons and become a positive ion. Fancy name. Here you go, a little vocabulary word for the next test. What do you call an ion that has a positive charge? And you can always tell if somebody has taken chemistry or not. The word is C-A-T-I-O-N. If they've never taken chemistry, they'll call it a cation. If they've taken chemistry, they'll know to call it a cation. A cation is a positive ion. Now here's what I do as a memory trick for me. I write the word cation and I write the T as a plus sign. That's easy for me to remember now that cations are positive ions. You get that? Now, there's a fancy name for negative ions. It's called anion. Here's my memory trick. A negative ion. And that's my memory trick, that anion means I'm a negative ion. Now, watch what happens here, okay? I become what? I become positively charged ion, a cation, and I gained a negative electron, and I become negative. Why do they stay together like this? Why do they stay together and form a compound? The compound's called lithium chloride. Why would they do that? Hey, I have a tendency to lose an electron. Well, you did. And I have a tendency to gain one. Well, you did. Why don't you just get away from me? And so what happened? What do you think? Look at my hands. What do you know about science that says I'm positively charged and you're negative? What happens if I put them together? Raise your hand if you know. And this is serious to me. This is actually more serious than you think. If you come this far and you're a 10th grader and all the science class you've had, it's very serious to me that you can't even raise your hand and say, what happens when you put a positive and negative thing together? Do they attract or repel? Now raise your hand if you know. You don't have to say the answer. All right, if you don't know this, there's something wrong. There's something wrong with your education. You got it? I'm going to say it out loud. What happens if you put negative and negative together? What happens? They repel. What if you have things that are like charges, plus and plus, they repel. Negative and negative, they repel. What about positive and negative charges? They attract. Everybody in this room should have had that easily. So guess what? I became a positive ion. I became a negative ion. I can't get away from you. I'm attracted to you, aren't I? So here's the big question for you today. What do you think you would call the bond? What is the chemical bond called that holds ions together? Give me a great name for a bond that would hold these two ions together. Raise your hand if you think you know. What do you got? Yes. And I agree, in middle school or even in ninth grade, you might have memorized ionic bond because it was a definition, because you probably didn't know what an ion really was. But now you know what an ion is, and you know that this ion is positive, this is negative, and they're attracted to each other. And what do you call a bond that holds two ions together? An ionic bond. What do you call a compound that's made with a metal and a non-metal ion? What do you call a compound that's a metal ion and a non-metal ion? It starts with an I. What kind of a compound is it? Raise your hand if you know. It's called an ionic compound. What? An ionic compound is between a metal ion and a non-metal ion. You get it? Now, there's another name for an ionic compound. It's 4 letters long. Here we go. Oh, by the way, what are ionic compounds made of? Starts with an I. Ions. What kind of bond holds the ions together? Ionic bonds. And what kind of compound is it? Ionic compound. Now there's another name for an ionic compound. Let's go down here. Lithium chloride is a blank compound. What are you going to put here? What kind of a compound is it? Lithium chloride is ionic and held together by what kind of bond? Ionic. And it's made up of what? Ions that have opposite charges. Now, I want to show you one more word. In chemistry, any ionic compound, any, is also called a salt. An ionic compound is a salt. Now, what is the most famous salt in the world? What's the one you have at your house? Table salt. Now, table salt, if I were a middle school teacher and I was going to do a little bit of chemistry, I would probably teach you to say NaCl. Have you heard that before? NaCl is table salt. Look, metal, non-metal. Yes? Now, this right here was lithium chloride. Is it salt? It is. It's not table salt, but it's an ionic compound. It's salt. Do you know that some people actually eat this instead of that? If the doctor says you have too much sodium in your diet, you can actually buy light salt. You can buy salt that's lithium chloride. It still tastes a little bit salty, but you don't get the sodium ions. Now, there are a lot of salts. I could make one up. Here, I'll make one up. Calcium fluoride. Yeah, that's a salt. Metal, non-metal. I wouldn't eat that one. Would you eat sodium arsenide? No, that'd be poisonous. Okay, arsenic. So there's a lot of salts I wouldn't eat. The one we tend to eat is sodium chloride. Did you know in the ocean there's at least 14 different salts? At least. So the ocean, guess what the number 1 salt in the ocean is? Take a wild guess. Sodium chloride. Have any of you in your house, if you buy regular salt like Morton salt or Food Lion salt, that's going to be sodium chloride. You know that? And maybe buy sea salt? How many of you have sea salt in your home? You use it? You know what? It's got many salts in it. Oh, what? Yeah, it has many salts in it. And that means many ionic compounds. All right, what do you think about this? Does this help you a little bit? This is actually what you need to know. You say, I took chemistry. Well, what do you know about chemistry? Well, I know that metals and nonmetals like to form ionic compounds. Why? Because the metals like to lose negative electrons and become positive ions, and the nonmetal likes to gain negative electrons and become negative ion. They can't get away from each other because opposite things are attracted with opposite charges, and that's called an ionic compound, called a salt. Okay, well now we're going to play the grid game. I'm going to help you with this, and what this does is it tells you whether or not you had that little brick wall in your brain, because there's a world called the world of mass and the world of charge. So I'm going to do one for you, and then I'm going to call you up, and I'll let you pick any one you want up here, okay? And you're going to say, I can do that one. And I'm going to give you credit for coming up here and just doing your best. As long as you try your best. If you make a little mistake, I'll help you a little bit, and then you finish the problem. You got that? Now, if I were going to take this home and study with it, I would write this stuff in one color and then write the other stuff in another. Because if you're going to study this for a test, for example, you need to know what was given to you and what did you have to come up with yourself. So I'm going to have a pencil up here. Actually, I want you to bring your own pencil, actually, instead of using mine. If you happen to have a pen with you, or if you're doing this in pencil, maybe get a pen out and put the answers in pen. So when you go home, you'll say, here's what was given to me, and here's what they had to come up with. Okay. All right, so everybody have two colored pens somewhere? All right, I would like to show you how to play the grid game. Now, I know it's not like a game like Jeopardy and you get points. It's not like that. But the game is right here in your mind. Okay, so here's what I'm going to show you how to play it. I made a little chart over here, and it's called the always things, world of mass, world of charge. So what I'd like you to do is, if you can do this for me, you'll understand what an isotope is. You're going to understand what an ion is. So here's what I'm going to do first. It always is. Let me tell you what's always true. Always, always, always. Everybody ready? When I look at this symbol, I saw a capital C. I'm not even looking at the 12. I'm not looking at that 12. I see a capital C, and I look up here. And does everybody have a periodic table with them? You need a periodic table. I'll go ahead and put one out here. When you come up here, I'll have a periodic table ready for you. All right. Now, excuse me. Here are the always is. When I look at the periodic table, capital C will always have what atomic number? It will always be what atomic number? Look up there. What should I put here? Let me use a different color. I promise you, carbon will always have the atomic number 6 on the periodic table. I also promise you that the atomic number is always the number of protons. Now, is everybody with me? Are you guys still getting ready? When you do yours, if I was doing this one, I'd look at capital H and do the same thing I did here. Capital C has to be atomic number 6. The atomic number is always number of protons. Now, I'm going to put a little check mark here because you know what? I just finished the alwayses. Now, I don't really care if you jump into the world of mass first or charge. It doesn't matter which one you do first. And here's what I'm going to do here. I happen to notice this little 12 in the upper left-hand corner. What is that? Is that world of mass or charge? What do you think? Mass, isn't it? That's the mass number. Oh, the mass number for this isotope. You asked about isotopes, Leila. This carbon has a mass of 12. Not all of them. They don't all have a mass of 12. This one does. Now, I'm not done with the world of mass yet because you know what this means? You have 12 things in your nucleus. Isn't that what it is? The mass number is the number of things in your nucleus. 12 things are in your nucleus, and 6 of them are protons? What does that mean? There's 12 things in your nucleus, and 6 of them are protons. What else do I know then? Roy, help me out.
6 neutrons.
Yes. You know that these two have to do with the world of mass, don't you? Now, I'm done with the world of mass. Now, I'm going to go into the world of charge. And what I remember protons are positive, electrons are negative. Now, I look in the upper right-hand corner. What do I see? Nothing. What does that mean? What charge does it have? 0. How can you have no charge when I know you have 6 pluses? I know you have 6 pluses. How can you have no charge? You must have what? You must have 6 minuses. What's plus 6 and minus 6? And that's what it says, no charge. And that's how you play the grid game. I'll give you one more hint before I call you up here, okay? See this right here? First of all, do the always is first. Do the always is first. You want me to do that again? Do you know the always is? The always, look at that symbol. That symbol C will always, on the periodic table, will always be number 6, won't it? And that means you have every atom of carbon in the universe has 6 protons in the center of it. Quickly, I got the always is. I don't really care if you want to do charge and then mass or mass and then charge. Just do them separately, I got it? And I have one more hint for you. See this guy here? Whoever picks this one, I can tell you right now, look on the periodic table way down here. See that guy way down there? See 92? You eventually are going to put 92 protons here, aren't you? But guess what? When you do the world of charge, you're going to have 92 pluses. But how many minuses you're going to have? And I'll give you a clue. It's like a soccer game. The pluses have scored 92 goals, and the pluses are ahead by 2. How many electrons would you have? The protons are ahead by 2, and you have 92 protons. You got 92 pluses, and the pluses are ahead by 2. So how many electrons would that one have? 90. Got it? Whoever's ahead, that means you have one more of those than the other. Like one more electron, you have 2 more protons. All right. Are you ready? I would like you to, when you come up here, I can help you a little bit, all right? I can help you a little bit, but I promise you, when you get done from being up here, you're going to go sit, I'm going to ask you, say, do you think you understand this better? You're all going to say, I do. Making you come up here is going to make you understand it better. Okay, nobody's going to be embarrassed. Nobody's going to be embarrassed. We're just going to do them. We're just going to do them. All right, do I have a volunteer? Wow, okay. All right, you're first. You go up that. There's a periodic table. You just need to take a pencil. All right, I'm the judge, and I'm a nice judge. And which one would you like to do? So by the way, there are some hard ones on there, so maybe that's why you want to do one right away. Okay.
Yeah.
Which one are you going to do, Zach?
This one. 14.
Okay, the carbon 14?
Yes.
All right. I'm going to give you a little clue now. You're going to start with the always is. I'm listening.
So the always is, you know, since carbon atomic number is 6.
Wait, is carbon always number 6? Okay, I mean always? Always?
Yes.
Okay.
And then the protons are the same as the atomic number.
Wait. Always?
Yes.
Okay.
And then you check that off, right?
Is that why I call them the always is? Now, which world do you want to get into now? Doesn't matter.
Mass number.
Mass? Let's get into
yes.
the world of mass. What do you know about this guy?
That the mass number is 14. Is it that?
Do all carbon atoms have a mass of 14?
Nope.
All of them?
Nope.
No, they don't. Does this one have a mass of 14?
Yes.
You are correct. Keep going.
Can I have a little help? I kind of forgot.
Yes?
What's next?
All right, what does the mass number tell you?
The mass number.
Remember, the world of mass is the world of the nucleus.
Mm-hmm.
The mass number is the number of protons and neutrons. So 14 people came to your party. How many of them were protons?
6.
6? Well, then how many people were left over?
8
All right. 8 what?
neutrons.
Now, does your proton and neutron equal 14?
Yes.
Then you're done with the world of mass. What do you think? All right, now you're going to do the world of charge. Put a little check mark on the world of mass. All right, here we go. One more hurdle.
So since protons are, wait,
What do you see in the upper right-hand corner of your symbol?
nothing.
What does that mean?
That there's no charge.
Yes. How can you have no charge though, because you have 6 protons, you have 6 positive charges.
Uh-huh. So they would have to cancel out. So
Say it again?
They would have to cancel out
What's gonna cancel out?
the electrons and the protons.
Yes.
So that would
How
be
many electrons?
6.
Oh, darn it. Wait a minute. Sorry, blue screen. All right, go ahead.
So since they cancel out, they would have to be 6.
So if you had 6 pluses and 6 minuses, that's it.
Mhm.
Good job. Good job. All right. All right, next volunteer. Math. Now, I wouldn't mind, if you really thought you understood this, I wouldn't mind if some of you waited a little bit longer and took some of the harder ones. You understand that? I know what you were thinking. I'd rather go early because they're easier than some of the other ones, but some of you might want to wait. I'll help you anyway. Hi, Zach. Good job. Which one are you doing, Madison?
This one.
Okay, make sure you're real loud so I can hear you.
Okay. So the atomic number for this one is 92.
Always?
Yes.
Is uranium always 92?
Yes.
Okay. All right.
And so the atomic number is protons.
Wait, always?
Yes.
Okay.
And then the
Check off
mass.
the always box. What word do you want to go to?
Okay.
World of mass or world of charge?
Mass.
Okay.
So the mass number is 235.
Are all uraniums 235?
Yes.
No.
No.
Is this isotope
Yes.
235?
Yes.
You know why I said that? Because it's not one that always is it? All right.
Okay. And then the mass number is always protons and neutrons.
Yes.
So the neutrons would be 133, I think.
I think it's 143. Is that right? Are you done with the world of mass?
Yes.
All right. World
Um,
of charge.
and then since there's +2, there's more protons, so there'd be
Protons are head by 2.
wouldn't that just be 92?
What are you gonna write down there? They're head by 2.
Wouldn't it just be 92?
Say it real loud.
92,
No,
94.
wait. The protons are head by 2, and there are 92 protons. Imagine it's a basketball game. Protons are head by 2, and protons have 92. What's the score for the electrons? Yes. What do you think? Good job. All right. Next. Good job. All right, Layla. And again, I would appreciate if you really do catch on to wait a little longer if you want to do some of the harder ones. And also, I don't like the math just like you don't, but you try to talk as clear as you can because we're way back here, okay? It's no good if Zach can't hear what you're saying, it's no good. All right, I'm ready. Which one do you want to do?
This one.
All right.
Okay, so its atomic number is 11.
Who, for sodium?
Yes.
Is it always 11 for sodium? Always? Okay. Just making sure.
And then the mass number is 24.
No, wait. You're not done with the always is yet.
Oh, sorry.
Wait, what's that? Why'd you put 11 there?
Because the number of protons is always the same as
Always? Okay. Okay, now you can check off the box called always is.
And then the atomic number is 24.
Does sodium always have, that's called mass number, right? Is it always 24 for sodium?
No.
Is this isotope 24? Okay.
And then you can subtract the atomic number by the mass number to get the number of neutrons. So that would be, oops. What is it? Hold on. Oh, it would be 13.
How much?
13.
That's it. You're down to the world of mass. That's good. Put a little check mark. All right, one more hurdle.
It has more positive
Say it again.
charges. It has more positive
How
charges.
many more?
One more.
Okay.
I'm not really sure how to do that.
All right, let's say we're playing a game, and who's ahead? Are the pluses ahead or the minuses ahead?
The pluses.
They're ahead by 1, right? And what is their score? What's the score for the protons?
11.
They're ahead by 1.
Oh, 12.
So what's the score for the electrons?
10.
What do you think? All right, good job. Oh, now we're seeing a bunch of hands go up. All right, Sierra, you get to pick one, all right? Wow, that was good. Does it also give you more confidence? Do you see other people doing this? Does that help you? Do you not feel better after you did this?
Yes, I do.
I told you you would. All right, ready. Which one do you want to do?
I did this one.
Woo! All right, you're doing the hard one. All right, let's go.
So this one has to be 1, because that one's 1.
Why?
Because the atomic number is the number of protons,
Always.
always. So,
Now, you're not ready to check that box yet because there's one more thing
Oh.
that goes with always.
and it'd be
Yes. Yes.
hydrogen, because that's that.
Hydrogen's always number 1. All right. Wow, you took one of the hard ones.
And then since the mass number is 2, and
Yeah.
there's 1 proton, that means there has to be 1 neutron.
All right. Are you done with the world of mass yet? Nope.
No,
Not yet. You have to have one more number somewhere.
and this would be 2.
Yes. Yes. You have to tell me that this isotope had a mass of 2. You did. You're doing great.
And then since, I mean, that's already there, but since,
What about the world of charge now?
that's 0 because
Because I said it
there's-
was 0.
Yeah, because you said it.
So what's the charge?
Positive. No,
Allowed.
neutral. Is it? Oh, wait, it'd be +1. +1, sorry.
And why did you say that?
Because there's no electrons and there's 1 more.
You had 1 proton
Yeah.
and no electrons, right?
Yeah.
Excellent. Great job. All right. Woo-hoo! All right, hang on. I gotta mark it down. I'm gonna save some of you for some of the harder ones. May, all right, go ahead. May, you know what? If you wanna go up there, May, and you wanna pick one of the hard ones, just show off a little bit, okay? Take a pencil. May, take a pencil. All right, here we go. Now, there's some, if you have to move the camera up on the paper, if you want to do some of the hard ones down the bottom, but you can do any of the one you want. Pick, which one you want to do?
Let's go with this.
Okay, here we go.
All right, so is that hydrogen?
I think so.
Okay, so that has
You're gonna do always as first.
always its atomic number is 1.
For
So,
hydrogen, always?
there's the 1.
Wait, is hydrogen always atomic number 1?
No. Yeah,
It
yes.
is.
Yes.
It is.
So we got that.
Go ahead.
And number of protons is also 1. So
Always for hydrogen?
mhm.
Okay. Check off the always box.
Now we're doing the world of mass, and the mass number is.
I wouldn't look on a periodic table.
Well, let's see.
Because they can have different masses.
3,
Question mark 3?
3, with the
It is
exclamation
3.
point.
This isotope has a mass of 3.
Yes, it does. All right. So now we're gonna do the number of neutrons, which is 3.
How'd you get that? Wait a minute. How'd you get that?
Well,
The
I
mass
think,
number means how many protons and neutrons are in the nucleus.
okay, so it could be,
Could be.
I'm struggling, trying to think about it.
3 people came to the party, a nucleus party, and one of them was a proton boy.
Oh, yeah?
So how many are neutron girls?
2.
See, that's easy for you, isn't it?
Yeah.
If I say party, it's easy.
Yeah.
Why is it hard? Because I say atom.
That's a great question. I'm trying to think. Okay, so
Okay,
how do you know? We know we have three.
3 things in a nucleus.
How do I know which ones are neutrons and which ones are electrons?
Okay, because in the world of mass, that's the world, who's in the nucleus?
Say it again.
Who's in the nucleus? What particles are in the nucleus?
Neutrons,
And?
not electrons. So it's
Neutrons and
neutrons and
Neutrons
protons.
and protons.
Yes.
Okay, the mass number is how many protons and neutrons there are.
So three.
Okay, now how many of those 3 are protons?
Three?
Look at it.
Ah,
What do you have for protons?
protons. I wrote one. Oh, two.
All right.
I
So
see.
1 proton and,
Two neutrons.
don't say electrons in the world of mass.
I'm sorry, two neutrons.
All right, now you're down to the world of mass.
Yes. Okay. Now we have to find out how many electrons.
Yeah.
And 2 plus that at
Wait, what are you looking at for a world of charge?
okay, for the world of charge you look at your electrons.
And?
And that's it. Yeah, protons.
Okay. All right, well, who's ahead, protons or electrons?
I'm thinking
Look in the upper right-hand corner of your symbol.
protons have
They're
one.
ahead by 1, aren't they?
Yeah, so you
It's a
know
low-scoring game.
hmm,
Protons only have 1, and they're ahead by 1.
0.
Okay.
There's no charge.
Charge? Oh, yeah. What do you mean, no charge?
I mean, like
It
that
does have a
can't.
charge, it has a +1 charge.
It doesn't have like a negative for.
It doesn't have a negative charge.
Right.
Put a 0 there.
All right.
Ah, now does that add up to +1?
No. Wait. Was what add up to plus one?
What does +1 and 0 add up to be?
1.
+1.
Mm-hmm.
Is this guy an ion or not?
He is.
An ion is an atom that has a charge, is it?
Oh, so he is not an ion.
If you see an H +1, what does that mean?
Means that it has.
It's an ion.
Yeah.
Is it a cation or anion?
That I don't know.
If you write the word cation like the T like this,
Oh.
where the cations are positive ions.
So it's
Hey, do we have 3 more minutes or are we done? Just to go to 12? Will we go till 1? Will we go till 1 on Fridays? Is that right? Okay, all right, good job. You feel better?
I almost feel more confused after that.
Oh, really?
Like I thought I had it, and then I really questioned
One of the first people I've ever had that said that. All right, Roar. Roar. You want me to pick one for you? Or you want to pick one? I'll pick one. All right.
Okay.
You want to do that one that has 10, 10, 18 on it? Do you want to do the one that says 4,
10
minus
huh?
1?
Which one?
You want to do the next one?
Oh.
The very next one's a little bit harder, but the one
Yeah,
that has
that's a-
fluorine in it, try that one.
I'll do that one.
Okay.
Okay. So, fluorine, the atomic number is 9. It's always 9.
It is.
Yeah.
For fluorine, you're right.
Okay.
May, if you'll listen to her carefully, listen to what she says carefully and see if that'll help you a little bit also.
It's 9.
Okay?
Protons are also 9.
Okay.
Yeah.
Check off the always.
Okay. And then the mass number is 20.
For this isotope, it is.
It's not always 20.
Right.
Okay. And then that means that there are 11 neutrons
How do you know that?
because the number of neutrons is, because the mass number is 20, and if there's 9 protons, there has to be 11 left.
To add up to 20, right?
Yes.
You don't think we're the math.
And then there's a -1 electron, so
Because they're ahead by one.
that means that there's 10 electrons.
Very, very good, very good. All right, now, if you didn't go today, then you're gonna go on Monday, okay? All right? And, wait, here's what I'd like to do this weekend, you're gonna eventually turn in a piece of paper that has the scientists on them and what they did. It's not due till Wednesday, but if you wanna start this weekend, I'm gonna be doing some scientists on Monday. We're gonna finish the grid game on Monday, and I'm gonna do some scientists, all right? All right, have a nice weekend, yes.
I wonder if it'll bubble. I know.
Here's what I'd like to do. Here's what I'd like to do. First of all, you can rewrite it one more time, give it to me on Monday, and then you rewrite everything in your own writing, and then do your own calculations, and the right answer. Okay, then, I'll give you back those points. I see. All right, here's what I can do. You want to take the quiz, you want to be able to do one of these, okay? So you go ahead and do that this weekend. I'll give you. If you want to Yeah.